Today we're going to talk about a process that has been evolving over a couple of years. A couple of my colleagues have worked on this, so this is not all my ideas, but finally come up with a name for it: proactive architectural analysis of cybersecurity threats. So I've given this same presentation at a conference that was not as MBSE focused. So we're probably going to be able to skip through sort of the first two pieces pretty quickly. But then we can talk more about security analysis and then specifically threat modeling as a part of that. And then we'll get into sort of the actual implementation within an MBSE model. So once again, probably don't need to explain this one to you guys. The only thing that I will mention out of here, right, is the not portion over there. So we've heard a couple of people talk about how MBSE is not just about tools. Once again, I'm not going to be giving you guys a tool in this presentation, but I will be giving you guys a little bit of a process, right? So we've also talked about, or a couple of speakers have, about why diagramming and why sketching is not enough. Uniquely though, from the perspective of someone who is going to do threat modeling, if you read any of the books, the literature, a lot of times they talk about starting off with just sketching, right? And that is great if you're looking to learn, or if you're just trying to, say, threat model against a very small part of your system, right? But later on in the presentation, I'll kind of show, once we get to that analysis step, right, some of the major benefits for threat modeling that you get out of putting those threats and mitigations, etc., into a model. Once again, talking about system complexity, right? Whenever we are modeling threats against things like fighter jets, and we're looking at like 5 million lines of code. Again, diagrams are not going to quite be enough. And then additionally, whenever we have processes like this one on the left, which was an attempt at modeling the DevSecOps process within UAF, again, it's not going to be quite enough to just have a diagram. So the constituent pieces of an MBSE model. I'm also not going to be presenting a full model today, right? What I am going to give you is a little bit of the architecture design process piece. I'm also going to talk a little bit about the extensions to the modeling language that we had to implement to be able to capture threats in the model. However, I'm not going to talk about executability, still working on that. And then also not really going to talk about the digital modeling environment. Again, getting back to tools. So security analysis as kind of like the broader kind of area of focus, right, is going to have a lot of constituent pieces to it. And so it's going to span everything from your requirements, your architecture design, and into that DevSecOps actual implementation phase, right? And so we want to embed security analysis across all of those phases. We're particularly going to be focused on this, the do this portion, right, about threat modeling within your architecture. However, hopefully something that you can take away from this presentation is that if you kind of follow this process, it will allow you to then trace your threat modeling all the way to, say, your deployed system, where then you can use that to inform things like your threat hunting. Okay, so getting into the meat of it, whenever we're talking about threat modeling, we kind of want to answer 4 key questions, right? The first one being, what are we building? So whether you're threat modeling or not, if you're doing MBSE, hopefully you're answering this top question, right? So this comes kind of without saying whether you're going to threat model or not. You kind of need to answer that one, right? The second one is what can go wrong, right? So in this presentation, I'm going to talk about threat scenarios. If folks are more familiar with the safety domains, this would be your safety cases and defeaters, or assurance cases and defeaters, right? The third question is, what should we do about these wrongs? So this is going to be your security controls, right? So if anyone has ever read through all of NIST 853, right, that document. And then finally, right, did we do a good enough job of threat modeling? So that's where we're going to get sort of into the analysis piece that I think the model really helps with. So as I mentioned, we finally came up with a name for this process, and we call it packed bus. So the proactive piece, we'll kind of get into this. A lot of threat modeling tends to look at your solution, right? So I have a MySQL server version, whatever. What are the CVEs for that version, right? By proactive, what I mean is we want to look more at the logical architecture, right? We want to take that higher level view, start to mitigate, control those threats to our system before we've even made some of those implementation decisions. And then finally, the bus part, right? We're going to talk through UAF as a modeling framework, and then also Stride as our threat modeling methodology. But as I'll kind of touch on a little bit later, hopefully if you have your favorite framework or your favorite threat modeling methodology, you can still find some pieces that are extensible to that. So how many people have used or modeled within UAF? Okay, a couple, cool. I know it was referenced in a few other presentations, so I'm not going to harp on it too much. But what I will mention is UAF, I think, is uniquely positioned to give us that operational view that we're primarily going to be using within this methodology. But even still, as I'll show, we kind of had to extend that language a little bit to be able to capture our specific pieces. So Stride as a threat modeling methodology, if you've done threat modeling, you've probably heard of it. It's been around for quite a while. It's fairly mature. There's a lot of great literature out there about it. And the main thing that I want to convey is most people stop at the acronym or the mnemonic that is Stride, right? So spoofing, tampering, etc. But if you actually dig into some of the literature, there's like a really good book by Adam Shostak, right? Stride is more than just a mnemonic. There's guidance on how to apply Stride to your systems. And then additionally, we'll talk about it, but there are variants of Stride, including Stride per element and Stride per interaction. And we'll kind of show how those translate to our model views. Additionally, we've extended Stride with an additional S, which is scarcity of process. So this is a threat if something just is not getting done within your system. So the example that I like to use is, let's say you have a policy that you need to do code review before you merge code in, right? Well, what happens if someone just blindly clicks that approve button and things get merged in, right? That's a threat that the code review process or activity is not occurring. So as I was talking about during the break, right, I had to show the systems engineering V. I'm amazed that we've made it this far without seeing it. But the phrase is tools in a toolbox, right? So with Stride, we chose it because I think it's one of the more adaptable threat modeling methods. However, as you can see, there is a whole list of threat modeling methods here, and you can choose kind of based on like two aspects, right? So depending on where you are in your system's lifecycle, different methods are going to be more applicable, right? We're going to primarily be focused on this concept of operations to architecture and requirements phase. And so that's kind of where I think Stride tends to fit. If you are in the system implementation or integration and tests phase, right? If you know, say, all of your system states, you have state machine diagrams, maybe attack trees are a little bit better, right? You can start to see how a cybersecurity threat might traverse all of the different constituent pieces of your system. And then additionally, again, your favorite threat modeling method might not be up here. If you are in the automotive industry, right, you're probably stuck with, what is it, ISO 21434, I think. But hopefully, even if your favorite method or the method that you use is not up here, you can kind of see how the profile that we have developed is extensible to it. So I'm kind of getting into this packed bus process, right? First thing is to model the system. And so there are a kind of very minimum set of views that I've kind of enumerated here that you will need to be able to apply this method. However, obviously, this just these views are not going to give you your entire systems model, right? We're also going to be making references to things like requirements, which obviously are not modeled here. But views that you're going to need mainly are going to be in the operational. However, we also call out to the personnel taxonomy, right? So for your operational taxonomy, that's going to give you the structure of the various performers within your system. The connectivity diagrams are going to give you your data or your information flows between system elements. Your processes are going to give you those interactions, right? So those are going to be your activity diagrams if you're using your decoder ring for other frameworks. And then finally, your personnel taxonomy, like I said, we want to incorporate pieces of threat actors and also insider threats into our threat modeling method. So this is kind of the minimum set. Again, we'll be making references to other views that are not represented here, but you probably should have if you're assembling a model. So step 2, right? Once you have your system modeled, we want to then essentially work through that model in 2 different ways. I mentioned Stride has a per element variant, right? So with your operational taxonomy and connectivity, you can look at those different operational roles, those different operational performers, right? And look at how does each of the threats in Stride apply. Additionally, per interaction, right, same thing, but we're going through our process diagrams, seeing, okay, at what point in this process or what data flow, right, how could I, as an attacker, right, how could I cause an issue there? And then we've come up with this kind of Mad Libs style scenario template that helps a little bit later whenever we start integrating these various pieces into the model, right? So ideally, you have a couple of folks get together, brainstorm, you apply this Stride per element per interaction, and you generate a bunch of these threat scenarios in sort of the standard format. And so it's going to give you things like which actor, what are they attacking, which asset, how are they attacking it, and what's their objective, right? What effect do they want to achieve? And so with that, you can now start to generate these security taxonomy views. So within here, right, we have our threat captured within this block here, and our threat scenario goes into this text element, right? But then we are going to capture pieces of that scenario with our various relationships. So as I mentioned, we can model both against elements, but as well as activities or processes. So for instance, up here, we have the operational activity that is compromised by a particular threat scenario, right? Additionally, we have this causes relationship. So we can map which threat actors are actually capable of causing a particular threat scenario. Additionally, we want to map all of the affected system elements. So things like the operational performer, the information elements, and then additionally, for once we start to get into the analysis portion, right, who's going to own that particular risk? And then finally, because we all want to trace everything to requirements, right, we have this trace relationship between our operational activities and our requirements. And then additionally, this enhances relationship between our security controls. So we can trace a requirement to a particular threat that might be driving it. And then additionally, through this compromises relationship for our activities. So anyone that is super familiar with UAF probably saw a few relationships and a few elements on that last diagram that are not standard. And so this is the profile that I alluded to earlier that we created to capture these new blocks, these new relationships. And so you can see all of the new stuff is outlined in red. So things like the threat, the relationships between, say, the operational activity or process, attacks, etc. Okay, so once we've generated those security taxonomy views, right, the next kind of crucial step is to substantiate those threat scenarios. So like I said, we want to trace these threats that we model to security controls that need implemented. And even early in the design, right, those security controls are going to have some cost, right, to implement, whether that's a performance cost or just a, actual monetary cost. And so one of the things that we want to do is substantiate our threats, right? We don't want to just have some subject matter expert say, I think that, threat actor X could do Y. We want to actually pull into our model real world tactics, techniques, and procedures, right, TTPs, to prove that out. And so one of the ways that we've done this is by including within our model, federating with essentially models of CAPEC, ATT&CK, and Sparta, which if anyone out here has done threat modeling, these are great open source TTPs, as well as some defenses, right? And then for our security controls, right, we can do the same thing for defend, or again, I mentioned earlier, NIST 853. And so not only does this allow us to substantiate our scenarios, we can point to real world, hey, this is how hackers would do that, right? But also this helps with folks that are not cyber SMEs, right? If you have that attack matrix sitting in front of you and you can reference those TTPs, right, that can help you brainstorm, can help you generate ideas on how a particular system element might get hacked, might get affected, right? So by pulling these in, we're getting the substantiation, but also extending the ability to do this modeling to not just cyber SMEs. And then finally, last step in the process, right, is to start to analyze the model. And so the way that we want to do this, right, is to be able to identify, do we have any threats that we've identified that are not mitigated, right? So we've got kind of a series of matrices that we find particularly useful. One is a matrix that consists of all of our threat scenarios to all of our security controls, right? So if we have a threat scenario that has no security controls allocated to it, right? Probably not good. We probably need to revisit that threat scenario. Additionally, you can look at threats to operational roles or operational activities. And similarly, right, if there's a particular activity that has just a ton of threats registered against it, you probably want to spend a little bit more time thinking about how am I going to defend that particular part of my system. Additionally, if you have a system element that has no threats registered against it, you probably forgot about that during your brainstorming session, right? And so this is kind of an iterative process, right? So kind of laid out a 5-step sort of linear thing, but as your system definition increases, right, you can start to get a little bit more specific with the TTPs that you map to, the defenses that you put up, right? And then similarly, you could also apply this process at kind of your solution architecture level. Again, getting even more specific with TTPs once you make decisions about, okay, what actual database am I going to use? So again, this should be kind of an iterative process. It's not just a one and done, right? Just like systems modeling in general. So again, don't really need to drive home that MBSE is complex or that there's a long learning curve. I think we heard a couple of lessons on that from the last speaker, right? But to analyze and threat model against these large systems, right? Just like we need a model to do all of our other types of engineering tasks, same thing goes for security analysis, specifically threat modeling. And again, pulling in those databases of TTPs and such allows not just cyber SMEs to be able to do this, but systems engineers, and as we kind of talked about with the last questions from the last presentation, whoever you consider should be modeling, right? So that is it. A couple of resources there, but open for questions.
I have one for you, if I may.
Sure.
So at the end, you have a very nice, complex, complete model of the security. I'm just curious about the reviewing of those models by experts and the type of knowledge it takes to process of the information. Did you test it with external parties? Because when you model, you get internal knowledge that may be difficult to convey to the outside.
Yeah, so I only showed one of the matrices because I think that's still something that we're working on, is codifying like exactly which views of the model are going to give me the best information when it comes to folks that are familiar with threat modeling or like risk analysis, right? So probably a place that we could extend our profile, but it is, I think, still a work in progress.
And do you assign probabilities in that matrix?
We have not. So a couple of, I guess, other, I'll say limitations, right? So whenever we're looking at a particular threat with Stride, we are not necessarily assigning a probability, and we're also not considering things like the sequence that it might take to get to a particular threat scenario, right? So that's where something like attack trees, you're going to consider the full path, and that's where assigning a probability, then you can like do things like summation or weighting along that path, right? But we don't necessarily consider that. On one hand, if you put up really good defenses on the outside, you're going to have less probable threat scenarios on your internal parts of the system. Those zero trust may challenge that. But on the other hand, right, it doesn't matter how hard it is for a particular threat to manifest. We still want to have security controls in place. But, again, that associates a cost. And so, having an idea of how likely that is if you're trying to do things like costing would be helpful.
Just one little addition, that profile allows you to capture it. So we didn't, in our prototyping, we didn't go through the prioritization based on probability. So we did different analysis. But profile itself allows you to sign as soon as if you go through the risk analysis and probabilities.
I have a quick question for you, Alex. I think Natalia had mentioned earlier about the idea of happy modeling, where people use a best case scenario. How does your modeling address kind of the elasticity of type 1 and type 2 errors, where people are not going to implement things correctly? Users are going to have behaviors that are not in compliance with policy or rules. How do you address that in your modeling so you can see what is the prevalence of that and how to better address maze to eliminate it?
Yes, that's a good point. So this method is contingent on you having those not so happy paths modeled, right? Because if you look at it from a cybersecurity point of view, most of the time you're going to be abusing that rare functionality, that edge case, right? That error handling that's not properly implemented. So yeah, having your activity diagrams or your sequence diagrams that show what happens when an error occurs would be kind of crucial to make sure you capture that piece.
Yes, so the first step is to identify a threat. And if you go to the analysis further, you want to model the behavior of your threat actor, and including what happened, what they do on the system, and how system react in it, right? So this is not happy path. And when you do mitigation, you choose your mitigation. This is where you insert specific solution for mitigations. When you model misuse and abuse of a system, and introduce how your mitigation actually mitigating the case. So this is more detailed. That profile allows it, but it's actually architecting in your mitigation strategies.
Yeah, so for future cases where you're dealing with like applications, have you considered possibly implementing SBOM level vulnerabilities, like common weakness vulnerabilities, and maybe control correlation identifiers to STIG titles and vulnerability IDs? It gets real deep.
Sure. So we did kind of look at pulling in some elements of the CWE database, right? Because those are, again, the weaknesses are going to be inherent sometimes in your architectural decisions. Again, we're looking generally more at the logical level. So I haven't really explored as much, say, if you're modeling with actual resources and you have that SBOM type information. We haven't really explored modeling at that level, but yeah, it'd be interesting.
Your modeling is based on a human or human actor. What about the agentic AI coming into play? Now everybody talks about it. If a threat actor, somebody is putting the agents out, spawn it automatically and go and attack it. How are you modeling in your models?
Yeah, so our threat actor element right now does spawn from the post. And so while you would generally think of that as, I guess, a human user, I guess we don't necessarily capture anything in our profile that would prevent you from modeling an AI agent as your threat actor. But I guess haven't really considered that case, because I guess at the same time, your agents would also probably be tied back to some threat actor that's orchestrating them, right? The idea is that an actor would use ChatGPT, but then ChatGPT would be able to spawn its own agents. Yeah, I guess it's not a case that I have considered or had to model yet.
So let me chip in a little bit. So it's an actor. It doesn't matter if it's human and not human. You just model it, model the threat actor right? So there is a hierarchy in threat actors that can be I don't know, coding monkey or like opportunistic, like terrorists, like whatever. There is different role models, but it doesn't mean they're humans. It's pattern of behavior. If this pattern of behavior demonstrated by the AI or something else, it doesn't matter. It's still an actor in a system. So you can model it like that. There is like nothing preventing you. This is what it's taking level of abstraction. So you abstract from this is a human and this is a system and this is a code and this is a person pushing button. Doesn't matter in the system if you are working on a high level of abstraction. It's just an actor. Thank you.
Thank you. We will move to the next slide, please.